Hi, in this video we're going to talk about the Medallion architecture, which is a design principle commonly found in the data engineering world. Right off the bat, what is a Medallion architecture? And you can see here this is actually a term sort of coined by Databricks, one of the leading data and AI companies and platforms today. And just to iterate how they've expressed this term here, a medallion architecture is a data design pattern used to logically organize data in a lakehouse with the goal of incrementally and progressively improving the structure and quality of data as it flows through each layer of the architecture, from bronze to silver to gold layer tables. So medallion architecture, it goes by some other names as well as mentioned here. You might also hear it referred to as multi-hop architecture, or simply bronze, silver, gold. So this is a strategy for managing your data and doing so in a way that's going to be really scalable and really resilient. That's really the main benefits that I like to tell people first when I'm first explaining what this design is and why you should use it. And so essentially what it boils down to is you usually start out with some form of raw data, right? Like a JSON or CSV, or whatever your data format is, and you're ingesting this from your original source. So typically you might design an ETL process and you need to get it up and running quick, and so you may choose to just ingest that data and immediately process it and load it to wherever you need to, doing things like data validation, transformation, filtering, all these things all at the same time. And so this medallion architecture is really aiming at decoupling some of those steps into a layered approach, which is going to make it much easier for you to replay things when you need to. It's going to make it easier for you to build tailored tables that are specific for your business needs, business applications, that don't have to worry about some of the same steps over and over again. And so let's say we have some data coming in its raw form to our cloud storage, say Amazon S3. And let's say this data is formatted in JSON blob files. So we have JSON files that are landing in our S3 bucket, and our job as a data engineer is to build a architecture of data where we're taking this raw data and cleaning it up, doing some data quality checks, and maybe doing some aggregations towards the end that are going to make it more valuable as a data lake or some tables. And so what we'll do to start with is our bronze layer. Everything starts with the bronze layer. So the bronze is typically what you're going to find storing the raw data that you've ingested. And so if we're collecting data from some source and it's JSON, we might simply just keep that data in its JSON form in the bronze, or you can choose to use Delta Lake throughout. I recommend using Delta Lake format for all of your tables, even for the bronze raw. And this is really for still some of the benefits you get from Delta, like ACID level transactions and some of the auditability that you get in Databricks' platform as well. And so the bronze layer is where we're going to find the data in its most original state. And this is useful if you, let's say, need to research or troubleshoot why is your data pipeline failing, or why did the data transform a certain way when you expected it to do something otherwise. And so sometimes you just need to see what was the data in the form that I got it in to begin with. And that's where your bronze layer is going to become really, really useful. So the primary users of your bronze layer are usually going to be those that know the systems very well, like your data engineering team. The bronze layer is really meant for the extremely low-level technical audience who has to ensure that that data does have the correct normalization and cleaning performed on it. And that takes us into the second layer, which is commonly referred to as silver. So silver is where you're going to start doing things like the filtering, the cleaning, and augmenting of your data. And this is where you might take the raw data, and let's say you've identified an issue where every now and then a certain column always appears null or always appears with a known skewed value, like 9999 or something. That's one of the things that you wouldn't want to touch in the bronze layer because you want to know about that. You don't want to lose that insight into your original data. But in the silver layer, we have the ability to start cleaning that up to make it more accessible and user-friendly for our data and AI practitioners. And we could do things like maybe we filter out those values, which would be sort of a drop constraint, where if we really don't want this data anomaly or this data quality smell, we could just drop those rows altogether. Or we could update that in place, maybe replacing nulls with a 0 value, or enforcing a more strong schema on the table instead of a loosely typed one. Now, the type of user that's going to be using your silver layer is going to typically be really any data and AI practitioner or role. That could be other data engineers, data analysts, analytic engineers, data scientists, you name it. And that's because these are the tables that start to become much more clean and polished tables. And the only caveat is they're typically unaggregated. And so, your silver tables are typically going to be larger. They're typically going to be still partitioned in a way that's heavily based on time or the time of the events. And so really for certain use cases, silver makes a lot of sense. But for other use cases where maybe I just want to view metrics over larger intervals of time, like months or weeks, then that's really where we're going to get into the gold layer. Now then, the gold layer is typically organized into very niche project-specific or product-specific databases, and usually this is where the most aggregation is done. And so, for example, your silver table might be a very clean table, but it's still on an individual transaction basis, whereas the gold table may be a daily aggregation or a monthly aggregation or whatever the time interval is, or it may be aggregated on something else. And so that makes it really good for things like reporting or more performant queries that don't need that low-level transaction detail. Now, that said, that doesn't mean you can't do additional data quality checks and filtering or rules at this layer. It is pretty common to see that at this point as well, depending on whether this gold table is meant for a specific use case or not, and that use case needs something. So, for example, the silver table, again, might be a very detailed transactional table, and that table could contain, if you've got a data set that's essentially multi-tenant or multi-use. So let's say I've got a lot of products that have data in the same table or the same data set. My silver table is going to have all products pumping data into that, and the gold tables I might want to create on a per product basis. That's one example. And so you can imagine some filtering is going to be necessary to do that, as well as maybe some additional transformations that are specific to that product, just to make it more consumable by the end user for this gold table. That way they don't have to know the data as inside out as somebody that's using, say, the silver table or even the bronze table. Okay, now that we've had a high-level walkthrough of what a medallion architecture is, we're going to dive into a quick sample demonstration how you might look at a raw data set that you've given to begin with and go through the process of creating that bronze, silver, and gold layer for your end users. So here I'm using a Databricks notebook, and I'm simply accessing some sample data that Databricks provides. This data is a really well-known sample data set for data science and data engineering and analytics use cases. It's called the New York City taxi trips. If you haven't heard of it, you will probably hear of it several times throughout the future because it's a nice sample data set. So we'll start out by just reading our New York City taxi trips data, which comes in this table already. And I'll take a quick peek at the data using display. So you can see we've got some timestamps for the pickup and drop-off times, the trip distance, the total fare amount, a zip code from where they got picked up, and a zip code where they got dropped off. So, we could go through this data just eyeballing it and looking for things, or we could do some more scientific data analysis. But our first layer, we don't really have to worry about any of that, because our first layer, we want to keep the data as much in its raw form as possible. Now, what is its raw form? If you're ever unsure, you can always print the schema of your data. We've got this data as is with a pretty good schema. These are actually timestamps. These are doubles. These are integers. And so this looks pretty good. We're not going to have a lot of schema difference as we go from bronze to silver later. But a different thing you might see is these date times or just dates. A lot of times in your raw data, they may come in as a string. And so, if you're using a format like JSON, if that's what you've been given, JSON doesn't have as well of a schema or a type system. And so a lot of times you might have a bronze table with strings for the dates, and then your silver table may actually parse those strings. And if it fails to parse, then you have an opportunity to either track that in some way or drop those rows altogether because it has corrupt data. So I'm going to use SQL to define my bronze table. And just to begin with, we're going to create a schema and call this New York City Taxi Medallion. Next, we're going to create our bronze table. And I'll use the same schema that I just built, and then I'll call this table trips bronze. The schema for this table, we want to really keep it the same as the previous schema that we saw here above. So I'm really not going to change much just because this sample data set is so small. I am going to do this by hand, right? And since we're defining the table now, I can also use this as a good chance to set a very descriptive comment on the table, letting my users know this is the bronze or raw layer of the data. Before we run that, the one thing I will add to this bronze layer is an additional time step just to track when I inserted or ingested data into this table. So we'll call that ingested date time. And lastly, I still want to partition this table. In this case, maybe a date, since these trips are happening across different dates. That might be a good idea, and it's actually pretty common with the bronze tables that you do partition it off of some temporal value, a date, or date, a month, date, even down to hour or more granular, depending on the size of the data and how much variety you have across that time. So we'll just create a column called ingested date as well, which is simply going to be the date value from this timestamp above it, and we will partition it by ingested date. Great, now that we've defined our table, we can go ahead and proceed to writing our raw data into the table. So since I have this as the df variable, I'm just going to do the minimal processing, which was adding our ingested date time and ingested date columns, and then we'll save that into our bronze table. And for sanity's sake, it's always a good idea to display or show your data frame to make sure that it looks as you expect. And ours does. We have our two timestamp columns at the end. And now we're ready to save that into a table, which, as you recall, we named up here above. I'll just copy that. New York City Taxi Medallion .trips bronze. So now we're ready to start working on our silver table, and I'm just going to pick one or two things to really clean up with this. There's not much. And so I can see here as an example, we have a row where trip distance is 0, and that's pretty odd. We would think that the trip would have some distance no matter what. So I'd like to filter out any rows such as that. But I'm really not sure how big of a problem is that, first of all. And so I might select from my table where trip distance I'll even go less than or equal to 0 because we should not have a negative either. Okay, so 76 rows with that. So it's definitely a worthwhile data constraint or data quality rule to build into our process. And I'm going to use the silver layer as an opportunity to clean that up. And so my silver layer, we're going to do the same thing where we define a table and then write into it. So let me copy this statement and we will revise this. So this table is going to be named trips silver. It's going to have the same data. We don't really want to drop anything here. We just want to clean things up. So in this case, I'm going to keep all of that the same. I'm even going to keep these as the same so that we know when it was ingested to the bronze layer. And partitioning is still fine to leave this as well. The only thing that's really going to change in my case is the filtering. So once I create this, we're going to do the same thing where we create our data frame, represents the silver data. But since silver is actually based on the bronze data, I actually will have silver equals bronze and then do my transformations from there. So we're going to filter where, and you could use the filter function as well, but we'll say bronze where trip distance is greater than 0. If it's not greater than 0, we want to drop those rows. Okay, and then just like before, we're going to write this into our table. Great. And of course, if you wanted to do a sanity check where trip distance is less than or equal to 0, we should get 0 results from this. Okay, and then lastly for our gold layer, we're going to create just one gold table. Now, of course, the gold layer, being the gold layer, you could create several tables on this because you're going to have a lot of different use cases and you might aggregate differently for certain tables than others. You might filter to certain things. Maybe one of these we do a daily aggregation. Maybe we do another gold table that's monthly. So there's all sorts of things that you could do, and you could very easily have multiple gold tables. But for the sake of this example, we're going to just create one. And the gold table I'm going to just do a aggregation by date. So in this case, I'm going to rename it gold, but I'm also going to change that name slightly just to be representative. So we'll say daily trips or daily count. And this one I want to show how many trips actually happened or were recorded by date. And so the date that we're really interested in is not our ingested date because we may have ingested this data late. We're really interested in the event date. So what I'm going to have to do is parse the date from this pickup time, which will be pretty straightforward. We will name or change our comment to gold aggregation of number of trips by day. And instead of these values, I'm going to have the pickup date as a date, and then I'll have trips, which will be an integer. And then we really don't necessarily need to partition this, so I'm going to actually remove the partition in this example, and we'll get that table defined. Now then, to create or do our transformation and processing, we're going to start with the previous layer, which was silver. And there you have it. We have an aggregation by date, counting the number of trips, and displaying it I can sort by. So lastly, we'll get that written into our gold table. So that is the Medallion architecture coined by Databricks. I hope you found this video useful. Please hit the like button. Thank you for watching, and I will see you next time.